In this video, I will provide you with the framing square positions that you can use to figure out every angle for a gable roof using common roof framing ratios like 8 and 12, 6 and 12, and in our example, we're going to be using a 4 and 12 roof pitch ratio, and that will become obvious once I break out the framing square. But the first thing I want to do is provide you with the level and plumb cut angles. So let's go ahead and break out our trusty level, and this right here is going to represent a plumb cut. You will hear that in a variety of different videos. Any cut that is vertical, like this one right here, is going to be a plumb cut. And you guessed it, any cut running horizontal, or like this one right here, is going to be referred to as a level cut. And to figure out the angles for those cuts on our roof rafter, we're simply going to line the framing square up with the edge of the roof rafter with the 12-inch mark on one side and the 4-inch mark on the other side. And if I was going to use a 6 and 12 roof ratio, I would leave the 12 alone and move the framing square to where the 6 would be positioned at the edge of the roof rafter instead of the 4. So basically, any vertical measurement or horizontal measurement after the roof rafter has been installed will be able to be created by using this example here, including the fascia board plumb cut angle. Again, we're going to be lining up our 4 and 12 measurements on our framing square. And we don't have to use the inside of the framing square. We can use the outside of the framing square also. And we can even reposition the framing square and sometimes even flip the framing square over to lay out other angles also. And you can see here where this position is going to work better than this position here for the plumb cut angle at the top of the roof rafter. So again, we're just lining up the 4 and the 12 here and flipping the framing square over. And we can do the same for our gable studs. The top angle again is going to be created by lining up the 4-inch and the 12-inch measurements on the framing square. And if we weren't going to have a rafter tail or the overhang and needed a plumb cut at the bottom, we could simply position the framing square again to lay out this line on our roof rafter. And if I needed to lay out the cuts for the fascia board support boards, we can simply line the framing square up like this and lay out those marks. And these notches are normally spaced 32 inches apart. However, yours might need to be closer depending upon whether or not the fascia board is going to be larger, or the distance from the fascia board might be a little further out, or you might be installing heavier roofing materials like roof tile. And if we are going to have a square cut at the end, this one here is a little obvious. We can simply move the framing square to the end and mark the desired distance for the overhang with a 90-degree angle. And if you need the angle for the top of the blocks, then again, we're going to be able to use the framing square for that also. And since I can't think of any other angles you're going to need for your gable roof, here is another quick tip I would like to throw out there for stair builders who are looking for a little stronger connection at the top up here, where the last tread can be used to prevent the stair stringers from separating from the ledger. Now, obviously, this is a little extreme here, so let's go ahead and put that thing back together. And this is normally how it's done. We're going to nail the treads to the stringers. However, if we nail the tread to the ledger, we're going to create a stronger connection point between the stringer and the ledger. We're basically going to use the tread to make that connection stronger by simply attaching it to the ledger. And for those of you who want to even make it a little stronger, then cut the tread a little larger so that we're not going to be nailing at the edge of the ledger. And in this example here, we are using 3/4 inch OSB. And you can see here where the nails are going to be centered in the ledger a little better instead of on the edge. And to do this, all we need to do is have the tread go back a little further and have the riser sit on top of it. Because as someone who has built a lot of stairs in their career, I can tell you that this particular tip right here isn't going to cost you that much more money to create a stronger connection at the top of your stairway. The concept of this video is going to be a lot easier to wrap your mind around than some of my other videos about roof framing or home building. And in this video, we're going to talk about tiling around a round shaped curve and how larger tiles might not give you the look you want. And how do I know this? Because I drive past a sign to an apartment building that looks something like this. And if this is the look you're looking for, great. And for those of you who don't want to watch any more of the video, then just use smaller tiles, maybe a 1-inch tile, mosaic tiles. Just don't use larger tiles on smaller radiuses because you're going to end up with something like this. So not too difficult. In our example here, we have a 1-foot radius with 6-inch tiles. Over here we have a 4-foot diameter or a 2-foot radius with 6-inch tiles. You can see how they're working a little bit better over here. And I would imagine if I had a 10-foot diameter or a 20-foot diameter, then the 6-inch tiles might work even better. Next up, let's go ahead and cut these tiles in half. Here is a 3-inch tile. 3 inches wide, 6 inches tall. And you can see where something like this doesn't look that bad. And if we go to a 1-inch wide tile, we're going to end up with something like this. And like I said, if this isn't the design you want, then I understand. Go ahead and use larger tiles for your curves. Here is another problem that you should be aware of if you are going to be adding a porch to an existing home with a truss roof, with a situation where you will have 2x4 top cords and will be using a larger rafter. And if you cut a regular seat cut, the rafter is going to be sitting a little too high to blend in with the existing roof. And I realize this isn't going to happen that often. But what about when somebody installs a porch beam, even with the top of the framing plates, because they haven't taken enough time to do a little planning and they end up destroying the bottom of the roof rafter to make it fit? And I can't tell you how many times I come across a situation like this where this section of the roof rafter is not structurally supported. And in reality, you just took a 2x10 and turned it into a 2x4 or a 2x6 when all you needed to do was lower the porch beam, unless you're not going to have enough headroom. Headroom clearance here is going to be a problem if you have 8-foot walls on the inside of the house. And if that's going to be the case, you might need to install 4x8s or 6x6s for your roof rafters, or even roof trusses, or modify the design of the porch to create something that is going to be accepted by your local building department. And I realize I made this sound a little easier than it's going to be on some of the projects. So use it if it works. If not, feel free to email me some pictures of your situation and I will try and take a look at it and see if I can come up with something useful. Here is a problem that I had when I was building my first 2-story home addition, and that's the fact that you are not allowed to wet vent between floors. So in this situation here, we have a dry vent. The dry vent goes all the way down to the drain for our toilet and is no way a wet vent. So we're not using a wet vent here because we don't have another fixture attaching to the vent pipe. And the drain line in this situation here is going to be from here going this way to your septic tank or your sewer. And the dry vent is going to be going from this point here all the way out through your roof. And I went ahead and put a clean out in here to provide you with an example of what I tried to do. I tried to tie into a 3-inch line that I had for the lower floor so that I could run a drain line up to the 2-story home addition. And when the inspector came out, he says, "No way, not allowed to do it." So what I had to do was run a separate drain line from this section of the plumbing. So remember, the drain line is right here going down. The vent is from here going up. So I'm allowed to tie a new drain line into the existing drain line. However, I'm not allowed to tie a drain line into the vent, because the moment I do that, it's going to become a wet vent. And that's the situation we're going to have here if we install another fixture. On the same floor, I'm allowed to install a wet vent on the same floor, as long as all of the pipe fittings, pipe sizes, and connections meet with local building code requirements. So again, let's go ahead and take a look at the drain again. The drain line is going to be from here down, and our wet vent is now going to be from here to here to allow for the wastewater from this fixture to drain into the vent. So this area right here is a wet vent, and we can do this on the same floor. And I do have other videos on wet venting if you need more information. And hopefully by now you're starting to get it. We cannot install another fixture on the floor above, because now the wet vent area would be going between the floors. The wet vent is now from here all the way down the fitting where the toilet arm comes off of. So let's go ahead and wrap this video up by showing you what would be acceptable. And then of course would be a dry vent pipe going in between the floors and not a wet vent. Here is a video that will be helpful for anyone who has a floor with 2x6 or 2x8 floor joist and would like to drill a hole through that, or might be figuring out whether or not your joists need to be replaced because someone drilled a hole in the wrong spot or too large of a hole. And according to the 2021 IPC, or International Plumbing Code, in the structural safety section, and I will put the building code reference number in the video description box, you cannot drill any section of your hole in the upper or lower 2 inches of your floor joist. And the diameter of that hole should not be larger than 1/3 of the floor joist. So even though for a 2x6, 1/3 of the area is a little larger than 1.5 inches, the maximum diameter of your hole and the placement of that hole can only be located in this section here. So the 1/3 rule on the height of the joist gets kicked out of the window. However, that will not be the case on a 2x8 that is 7.5 inches tall, providing us with a maximum diameter of the hole for 2.5 inches. And again, this hole cannot be located anywhere within the 2-inch section located at the top or bottom of the floor joist. This will not make your building inspector happy. And the information I just provided you with about the 2 inches and the maximum 1/3 diameter of the height of the joist will usually apply to other construction standard lumber floor joists like 2x10s or 2x12s also. However, if you're working with a structural engineer or your local building department, make sure that you verify this information with them before proceeding, because the last thing you want to do is find out that you're dealing with an unusual situation that might not allow you to drill any holes in your floor joist. In this video, I want to go over something that's been bothering me for quite some time, and that's the fact that people are building their own roof trusses for small buildings or small sheds when you really don't have to. And why should you spend the extra time building something that might fall apart anyway? So I'm here to tell you that the old tried and true ridge, rafter, and collar ties will be the way to go if you actually want to build something faster. And I do understand that some of you will be able to build something with roof trusses faster than you would a conventionally framed roof, because the idea of pre-assembling the roof trusses might seem to be easier than building a conventionally framed roof. I get that. And if that's the case, then that might be your only option. However, for someone like myself, this is a no-brainer, because if all of the components were cut for both types of roofs, I could probably assemble the conventionally framed roof in about the time it would take somebody just to build the roof trusses. And if I was using the correct lumber sizes, I wouldn't have to worry about the trusses being built incorrectly or with the wrong building hardware or connectors that could end up failing over time. Here's another home addition roof design idea. For example, if you're going to be adding a second story home addition and you have a situation like this where you have an existing roof here and a new roof over here. And obviously, if this was going to be a home addition, you would just simply rotate the roof 90 degrees. And I will provide you with an example of that at the end of the video. And in my first suggestion, I would suggest installing a roof drainage cricket. This is probably going to be the cheapest and easiest one to build. However, could trap a lot of snow if you live in an area where it snows a lot. And you're simply going to create a slope on both sides so that water can drain off of the roof. And I do have other videos on how to build a roof drainage cricket, and I'm sure those can be found at our website or by simply typing in roof drainage cricket into your favorite search engine. Another idea would be to come right off of the existing ridge and create a valley on each side. Now, something like this can also trap snow on each side, so make sure that you think about that before using this idea. Or you can create a shed roof like this. You would just simply add this section on. You can see the existing roof here. So here's another design that might work for you. And of course, my last idea, however, this is not going to be all of the ideas, but hopefully one of my ideas will inspire you to help you create something better if that's going to work for your project. However, if you wanted to, you could always rip the roof off of the lower area and rebuild it to where it would look something like this. And of course, all of these ideas will depend upon how much money you have or are willing to spend on your project as to which ones are going to work better for you. Here is another thing you can do when you are building stairs, and you would actually like them to turn out as nice as they possibly can. And that would be to stack your stair stringers on top of each other before they're installed so that you can check for any imperfections. And to do that, you're either going to line the back of it up, you're going to line the front of it up, because if your imperfections are only about 1/16 of an inch, then I wouldn't even worry about it. What you're going to be looking for will be imperfections that are going to be a little bit larger. So here you can see where everything looks good, and you've done a good job cutting your stringers at the top. And again, if this was off just a little bit at either the bottom or the top, then you can probably let it go. However, if it's off quite a bit, then you're going to need to make some adjustments to it. Or at least I would recommend that you make some adjustments to it. And you can do that by adding shims or shaped strips of lumber like we did here. And I would recommend using some type of an adhesive along with some small nails or screws to attach the shim to the stringers. And I will be making a future video to show you what happens if you don't fix this before you install your stair stringers. So here we had some imperfections that needed to be filled, and we used shims to do that. However, you could end up with an imperfection like this that needs to be trimmed. And if that happens, just simply grab your saw and recut that part of the stringer, or use a planer or some type of a sanding device to trim the wood off. Now, I've also used belt sanders to flatten some of these imperfections out also. And the last thing I would like to suggest would be that if you have too many imperfections, then you might consider recutting the stair stringers. Here's something that most engineers understand, and even some builders, when it comes to connecting two corners with shear panel or even exterior sheathing to create a stronger bond. So let's go ahead and take a look at the first one here, just a regular 2x4 at the end. And this situation here might have 3 2x4s right next to each other to provide you with drywall backing for the inside. And you can see here how the nails are going to be used to attach the shear panel to the framing stud. So here we just have one framing stud. However, most of the time we're going to have 2 additional framing studs with the possibility of a hold down. And a hold down is going to be used to securely fasten or anchor either a post or framing studs to the concrete foundation with the help of a larger anchor bolt. And I'll show you how that will be installed at the end of the video. So a piece of framing hardware that will use either screws or bolts to attach it to the wall framing studs or post, and an anchor bolt that will be embedded into the building foundation. Now, if we're looking for something a little stronger, we can install a 4x4 post or even a 4x6 post. And a 4x6 post would be helpful if you have shear panel going on the inside and you're not planning on moving this framing stud over to run the shear panel through. And since we have a 4x4 here, we're going to be able to put more nails in it, or at the very least create an area that might not allow the lumber to split as easy. If we were to put a bunch of nails like this into a 2x4, and we're going to put all of these nails in the same spot going all the way down, you can see where something like this could split the lumber, and I've seen it done before. And if that's the case, you might consider staggering the nails. And this might actually be something that the engineer will require on the building plan. So if you see staggered nails at either the bottom, top, or the sides, then that would look something like this. If we had 6 inches on center nailing, then we would simply move one over, come down 3 inches, move it over, and then have 2 rows of nails, one over here, one over here. And of course, we could install the staggered nails on both sides, here and here. And now for the reason why I made the video, I've seen this happen too many times, where the structural engineer might require a hold down over here and intersecting walls with shear panel. It's something I recently came across that inspired me to make the video. And that would look something like this, where we have our shear panel on the interior wall, starting over at this point here. However, it's not starting at this point over here. Now, this right here is how I see it done a lot, because the engineer is going to call out for shear panel running on this wall and on this wall. However, they might not provide you with a detail on how to make this stronger, especially if you're going to be using a hold down. So you can see here where there is a gap between this shear wall and this shear wall. We've got some nails going into our framing stud, and the structural connection that I'm looking at here is basically going to be just in the top plates and any nails that would be attaching the framing studs together. And all we need to do to make this stronger is to install a 4x4 here and then run the shear panel over to here. And of course, we're going to have to redo the shear panel on the other side to make this connection stronger. You might not need to relocate the shear panel. Something like this might be okay, but why do it when all you need to do is break the shear panel on the center of the 4x4, so that instead of having 1.5 inches to nail the 2 pieces of plywood at the break together, you'll have 3.5 inches. And of course, by running the shear panel all the way over to the 4x4, like you're looking at in this example here, we're going to get an excellent connection between the 2 shear walls, because the engineer won't always have a detail like this. And of course, you can stagger the nailing, and there's no reason to notch the framing plates. You can simply notch the shear panel over the framing plates and then nail the stud over the shear panel. And you could always nail the heck out of this framing stud into the 4x4 and then put some additional nails through the shear panel on the other side if you're looking for a little more structural strength. But we're going to need something here for drywall backing. And of course, this is the main reason why most builders miss this. They frame the walls and then butt the shear panel up against the framing stud or the wall here. They don't let it run through, and it's not that difficult to do. And believe it or not, this is something I started doing years ago. I don't know when or if I ever came across a detail that required it. It was always done the other way, which this way here just seems so much better, especially if you're going to be using a hold down. If a hold down is required for either this wall here or this wall here. And that should look something like this, a 4x4 post with a hold down bolted to it and then another bolt, anchor bolt, attaching it to the building foundation or to the floor framing. And even though this one here won't always be called out by the structural engineer to be located right here, the corner one probably will. This is the ideal location for the corner and is probably going to be specified with a detail, or the engineer will provide you with a specific location on the floor plan. If this one here is not located here, it's over here, then you might want to point it out to the structural engineer to see if they want to move it. If not, locate it where the structural engineer on record for your building plans has it located. Because most engineers aren't going to want to go back and do any modifications without getting paid for it if they've already been approved by the local building department. In this video, I will provide you with another project that you might be able to build without a lot of complicated math or calculations. And we're simply going to have a deck with 3 steps. And the beauty of this is that you're going to be able to use 2x6 or 2x8. However, with this design, we might have a problem with the building code that requires a 4-inch sphere or a round ball to not be allowed to travel through any part of the stairway. And we're going to be at 4 inches here. If I have a 2x6 and then I put an 1.5 inch thick decking board on top of that, I'm going to be right at 4 inches. And if I use 2x8 for something like this, I'm going to be over 4 inches. And I'm also creating this design here to sit on top of soil. And I'm not about to suggest that these bottom boards won't rot. And I will leave it up to you if you need to make further modifications to this to meet local building codes or work in your area. Another good thing about this design is that we are not going to have any mitered corners. Everything is going to be a 90-degree angle. And that's going to make this project a lot easier to build also. And to calculate the lengths of the boards we're going to use for the smaller stringers, all we need to do is draw a straight line down here and then measure each one of the boards from that straight line. And that's going to give us the length of each board for these smaller stringers. So in other words, this board right here will be the same length as this board. This board here going back to the line will be the same as this one here. And I know that might seem confusing, but let's go ahead and motor on and continue with our tour here. Don't forget you can stop the video at any time. And of course, watch the video again if you miss something or if something isn't quite making sense. And don't forget that you can modify this design, like I mentioned earlier, by installing additional bracing, blocking, and structural supports. And you can connect each one of the 2x6s together with building hardware like straps or flat framing anchors, even blocks. Just make sure that you install some of these framing anchors on each side. If I was just going to install all of these framing anchors on this side, along with the straps, then it might allow the 2x6s to fold over at the breaks or where the 2x6s are going to be connecting to the other 2x6s. So we're going to need to install some type of support bracing on both sides. And another idea might be to use a block. And if you put the block in between 2 boards here and then attach it with screws or nails, something like this here on both sides, then you might be able to use that instead of something like this. And you might even be able to use dowels to fasten these together. And don't forget to check out other types of framing hardware that you can use to create stronger stair stringers. And to figure out this length here, we're simply going to lay out some of our decking boards until we get the desired width that we want. If you want to cut one of these in half or cut it down to create a specific shape, then go ahead and do that. I'm not doing that. This deck, to meet most building codes, needs to be 36 inches long or 36 inches wide here. And to get that, I think 36 inches is right about here. I made it a little bit longer. You can't make it shorter, but you can make it longer. And if we use this method here, we're going to be able to create a deck that doesn't have shorter boards in it. Our deck's going to look nicer, at least in my opinion. And we're going to do the same thing with our stair steps. 2 steps with a 2x6 is going to give us about an 11-inch wide step. And it's going to be important to keep all of our stair steps the same width or depth going in both directions. So if you can see here, we're just simply raising this step up here. And I'm going to do the same thing with this step here. And finally with our last step here. If you notice, I've created a flat section here. And we're going to use each section here to calculate the lengths of our decking and stringer boards. And this is the beauty of this right here. This really makes your job easy. And make sure that you figure out the width and the depth of the deck before you get started. So in other words, you might not need to cut any of these boards. For example, if I had 10-foot 2x6, I could lay the 10-foot 2x6 next to each other, put the desired gap in between each board if I'm going to have a gap in between each board, and then grab my measuring tape and measure the distance. And if I want to make this distance here the same as this distance here, so that both the width and the length or the depth of the deck will be the same size, then I can do that. And it wouldn't be that difficult to lay out your boards in this direction here with the desired gaps if you're going to have them, and have them run full length to get these measurements here. So the measurement for this board right here is going to be the measurement from right here to right here. The measurement for this board right here, this step, this 2x6, the second one down, is going to be measured from right here to right here. And this board here is going to be the measurement from the front of this right here all the way to the back. And you guessed it, this measurement here all the way from this point to this point is going to be the measurement of our bottom board. And now would be a good time to point out that the bottom board will need to be ripped down and made a little bit shorter. What you're going to do is take the height of the decking. 2x6, we're going to have 1.5 inches thick 2x6. We're going to subtract 1.5 inches off of the bottom board. So if we have a 5.5 inch wide 2x6, we're going to rip that down to where it's 4 inches wide. And that's going to allow you to make each riser height the same size. So again, these lower boards, all of them are going to be 1.5 inches shorter if we're using 1.5 inch decking. If I'm using 2-inch thick decking, then I'm going to subtract 2 inches off of my 2x6. And I won't be going into a lot of detail about that in this video. However, I do have plenty of other videos at our website. Make sure you check them out if that doesn't make sense. And in our design here, these are not going to be the same size because the width of this is shorter than the length. And you can see it right here. If I wanted to make this length here the same as this length here, then I would need to cut these boards a little shorter. For example, if I have 3 foot 3¼ inches as a measurement from here to here, I've figured out how many decking boards I'm going to need according to my local building code. Got to be bigger than 3 foot. Then the same is going to hold true for the width. I could simply cut these boards here 3 foot 3¼ inches to create a square landing, or a landing with the same measurement for the width as it would be for the depth. And that's going to change the measurement of some of our boards. And I could always make this 4 foot wide and this 4 foot long also, if it's going to work with our decking. In this video, I will provide you with a couple of reasons why your exterior deck might be sinking. And number one on the list is probably going to have something to do with the footing. And from there, we're going to go ahead and suggest that it might have something to do with either soil erosion, that could be from your sprinklers, a leaking water pipe like your hose bib, or even a gutter downspout that's located near the deck footings. or soil surrounding the footing, specifically underneath the footing, that was not properly compacted. And this can happen when you over dig the footing. Let's say you needed a footing that was going to be 12 inches deep and you dug your hole 14 inches and instead of leaving it, decided to fill it back up with soil that wasn't compacted. And one of the reasons we dig a footing in the first place is to get a little lower to where the soil is going to be compacted a little bit better. However, this won't be the case all of the time. And to fix something like this, you might choose to remove the old footing and install one that's going to be a little bit larger. However, without knowing whether or not your soil is already compacted enough to support the footing and the deck in the first place is something that most of us, including myself, won't be able to figure out, and making the repair more difficult to figure out how you're going to fix it. The next item on the list is similar to the first one, except for the fact that you might be using some of these new products that sit on top of the uncompacted soil or somehow screw into the soil and come in a variety of different shapes and sizes. And I'm here to tell you that they aren't always going to work as well as a concrete footing. And if that's the case, you might consider replacing them with a concrete footing. And in our next example, this one here is going to be a little more obvious because you're going to be able to see it, and that's going to have something to do with the post or another structural part of the deck that has either termites or some type of wood damage that's causing the deck to sink a little bit. And another problem you might run into would be a post that is simply buried into the soil with or without a small footing. A lot of times you're going to have a small footing on something like this, or a concrete block or a couple of bricks underneath the post that's sinking into the soil. Now, I do have a video on how to fix some of this stuff at our website, because for this one here, you could simply pull the nails out of this and then put a block underneath the supporting beam so that you wouldn't have to remove the post if it wasn't damaged. And keep in mind that some of these repairs will need to be repaired again in the future if you're dealing with soil conditions that will not allow the footings to structurally support the deck. Here's another question from one of our viewers who built a house on an existing flat floor slab and is now dealing with water leaks around the perimeter of the building. And when I tried to explain to them what was going on, they simply suggested that they could add some type of a sealant, and that might work sometimes. And if you want to see an example of that, skip to the last section of the video. However, if not, let's go ahead and first take a look at standard construction with stucco and siding, where the weep screed for the stucco along with the building paper or even additional layers of building paper need to extend past the bottom of the framing plate or the top of the concrete building foundation floor to allow water, like when it's raining, to run off of the front of the building, around the front of the building foundation and onto the ground to prevent water from getting into those areas. So the weep screed you can see here is a little lower, and the building paper is going to go over that. And most building departments require 6 inches either from the top of the floor or the bottom of the stucco to the top of the soil for a situation like this, to allow for the water to drain off of the building. And in most cases, the ground should be sloping away from the building, also allowing the water to drain away from the building and not puddle up around the building. And if you pour a concrete sidewalk or patio around the building, they're usually going to want a 2-inch minimum from the bottom of the stucco or the bottom of the siding to the top of the concrete. And you can see here where a situation like this also will allow the water to drain away from the building if the concrete is sloping away from the building also. And of course, here is where the problem is going to go from bad to worse, by building a smaller building on top of a wider or larger concrete foundation that might also be an existing foundation, and not dropping the concrete down so that the standing water that sits on top of the concrete won't be able to flow in through any crack or crevice here and into the building where you might have a nice piece of carpeting or a natural wood floor that is going to get ruined. And I don't want to say you can't seal this somehow with some type of a sealant and metal flashing, but I can tell you that if you don't do anything, there's a good chance that you're going to end up with a situation like this unless you live in an area where it does not snow or rain. And even if this was sloping, you could still end up with a heavy downpour where the water would be backing up in this area and wouldn't be flowing away from the building as fast, allowing the water to get through any crack or crevice here and into your house. So what's the moral to this story? If you're going to build something on top of an existing concrete foundation, that you might want to figure out how to seal the area at the bottom here and deal with the fact that you might not have any concrete footings here. The concrete footings might be on the perimeter of the building, and that would be if there were any concrete footings to begin with in the first place. In this video, I will provide you with something that I used to use when I was straightening wall framing studs, and that was to simply move the bottom and the top of the wall framing stud over, or just the bottom, so that I wouldn't need to do as much planing on the one side or adding shims on the other side. And even though I'm not going to be providing you with all the details on how you straighten wall framing studs, I will provide you with an example of how I did it and the reasons why. So let's go ahead and get started with this right here. You can see where the wall framing stud is even with the top side of the wall framing plate and the bottom of the wall framing plate, and is a straight stud. In our next example, we're going to take a look at the same thing, except we're going to have a bowed stud. And you can see here where we have a gap between the straight edge and the face of the wall framing stud. And hopefully this makes sense. If not, let's just go ahead and kind of zoom around here to make sure that you know what we're looking at here. A bowed wall framing stud that is flush with both sides of the wall framing plates. And to straighten this wall framing stud, we're going to need to remove one side of the wall framing stud with a planer, which would be this area here, and we're going to need to add materials on the other side. And this is a common way of straightening studs. And I see carpenters using this method all the time, even when there are extreme cases where the studs are bowed more than an inch. And I'm here to tell you, you don't have to do that. If you simply move the wall framing stud over at the top a little bit. So in our example here, I moved it over 1/4 of an inch, and the wall framing stud has a 1/2 inch bow in the center. So again, we're going to be adding here, removing over here, adding on this side, and then doing the same that we did up here at the bottom. And it's going to provide us with a little stronger stud. So instead of having a wall framing stud where we've removed a 1/2 inch on one side, we're only going to remove 1/4 of an inch on that side. And it's going to give us a 3 1/4 inch wall framing stud all the way down, instead of having a 1/2 inch planed out of the center. And I will leave it up to you as to whether or not you think this is going to work better for your project. So again, I just simply moved the framing stud over 1/4 of an inch at the bottom and at the top. And we're going to be removing this part with a planer and then doing the same thing at the top. And we're actually going to be removing less materials, which means we're probably going to be adding less materials also. So hopefully this makes sense, because in our last example, we're going to take a look at what's left over on the wall framing stud. So in the example I just showed you, we're going to have a little bit more if we do it my way than we will if we take and leave the stud where it's at. And for those of you who like math, you cannot argue with the numbers. Here they are. And this is a 92¼ inch tall wall framing stud with a 1/2 inch bow in it. So we're going to need to remove a 1/2 inch from the center if we leave it where it's at, and 1/4 inch if we move it over. And I went ahead and made another example. I went ahead and created a wall framing stud with a 1-inch bow in it and left it where it was, moved it over 1/4 inch, and then moved it over a 1/2 inch. Let's go ahead and zoom in on the bottom here. Again, I moved this over a 1/2 inch on this one and 1/4 inch on this one here. And my guess is that most people are going to remove a wall framing stud with a 1-inch bow in it and replace it anyway. And for those of you who are not going to do that, let's just take a look at the numbers right here. They don't lie. You're going to benefit because this method here is going to provide you with more surface area for the existing wall framing stud, providing us with a better method for building. This video will be the first in a series I'm planning on doing to provide viewers with product information. This is something that has been requested for quite some time, probably since the day I started my channel. So let's go ahead with the first one, and that will be to provide you with a variety of different adhesives you might be able to use when attaching wood to wood in the situation where you have a tread connecting to a stringer. Or if you have a situation where you have a wood finished tread, like an oak tread, that needs to attach to plywood or OSB. And the first thing I need to point out is that if you are dealing with lumber that is going to shrink or expand and contract, like most construction standard lumber, plywood and OSB might not fall into this category or might not expand and contract as much as construction standard lumber. I've seen 2x12s shrink from 11.5 inches to 11.125 inches. And if you're using 2x12 for your stair stringers, which is probably the most common lumber used, you could end up with a gap between the tread and the stringer. And if you're using glue, you're using an adhesive that is not flexible or allows for movement, then it will actually separate and either stick to the stringer or the tread, providing you with a gap between either the adhesive and the tread or the adhesive and the stringer. Because as the stringer contracts or shrinks, it's going to pull away from the tread. So again, if you're using construction adhesive that is not elastic or flexible, then there's a good chance you're going to end up with your stairs squeaking. So what I would recommend would be to find a product with polyurethane in it. Now, I could swear that I used to use a product with polybutylene in it. However, since I couldn't find any products with polybutylene in it, then I have to figure out that I probably made a mistake and that it was actually polyurethane that I was referring to. Now, what I used to use was a window and door sealant, and they do not sell this product anymore. And it worked great. We used to use it on all of our floors and our stairs. And since that product is no longer available, I will not be able to provide you with its product information. Here is another question from one of our viewers, and if you have them, feel free to leave them in the comment area or email them to me. Some of them are pretty good, and some of them I can't use. But in this one here, I'm going to take an old house with a crawl space and subfloor framing where we're going to have joists sitting on top of a foundation stem wall, or in this case here, on top of a brick wall. And that would end up looking something like this after we formed it and poured it. And I'm going to go ahead and go over a step-by-step assembly process. However, I won't be providing you with every detail. So if you have any questions, feel free to leave them in the comment area and I will answer them as soon as possible. So the first thing I want to do is put a piece of sheet metal, run it across here to protect this side of the framing from any moisture that could come from this side over here. And for those of you who don't know what moisture does to wood, I would suggest watching a few more of our videos. So we are going to create a form that will go around the perimeter of our building, and the top of the form will be the same height as the top of the inside floor. unless you're going to be modifying one of the other sides. And there's a very good chance you will need to dig under the existing foundation a little bit. I've had to do this on quite a few buildings that I did because the new footings are usually a little deeper than the older footings. And depending upon the framing, you might need to add some blocks before installing the sheet metal. Just make sure that the sheet metal is installed before you pour the concrete. And make sure that the sheet metal isn't sticking up. I've actually made this mistake before and had to bend it over, and it won't be too bad for carpeting or other flooring. However, it could be a nightmare for the workers to walk across and trip over. And of course, that's the reason why I'm pointing it out. You might want to just lower it a little bit just to make sure that it isn't going to be sticking up. And after you remove the wall, you can add a furring strip here. And this will all depend upon what stage of the process you will need to do this. Because if you're going to leave these exterior walls to protect the interior of the existing building, which is what I usually did, then you'll simply add that furring strip later. Now, if you notice, we do not have any access to the crawl space from this side. And that's because we're not going to need it. We're going to be filling in the entire section of the new building foundation with concrete. So we will not need an access hole. We will not need to create an access hole from the inside of the foundation over here or create one on the outside of the building. However, if I was going to install a wood framed floor, then I would need access to the area underneath here. Next up, let's go ahead and take a look at some dowels that might be required by a structural engineer and the location along with the depth of how far they're going to go into the existing foundation will be provided by the structural engineer. Now, on a brick building like this one here, you might be required to modify it a little differently, and I will provide you with a little more information about that towards the end of the video. So in our example here, we are going to have number 4 rebar that is about 1/2 inch in diameter going around the middle of the footings. Our footings for the single-story room addition are going to be 12 inches wide and 12 inches deep. And then we're going to install our stem wall rebar and then install the inside form boards so that we can pour the footings and the stem wall at the same time. So we're not going to have a dowel here. The rebar here wouldn't go into the concrete or the brick. And on this side of the wall, we're only going to be able to go in the thickness of the wall. And that might only be about 8 inches. And I really don't think an engineer is going to do that with a brick wall. If it's concrete, that's probably going to be a thumbs up on that one. But on brick, it might require something different. So our rebar is going to be lapping. Don't forget our lap is going to be 40 times the diameter of the rebar. 1/2 inch rebar will require a minimum of a 20-inch lap, and that will be both here and where the dowels are. Next up, let's go ahead and install the inside form boards. And our form boards are going to be a little bit lower, or the thickness of the floor slab. And you can do this either way. I can either do it like this or raise the forms to the top of the floor so that the top of the stem wall will be the same height as the top of our floor. And I think either way will work fine. It will basically be up to you or your building designer as to what they choose to do. Just keep in mind that that is another option. And we will need a way to connect the floor slab to the stem walls. And that will be by using the shaped rebar here at a 90-degree angle. And that will make a little more sense once we get a little further in the video. Now, do not forget to install your anchor bolts. This information right here would be worth watching the entire video, because if your anchor bolts are longer than the thickness of the slab, then they're actually going to be embedded in the stem walls. And yes, I have seen that mistake made, even though I have not had the pleasure of making that one myself. And even though I have the rebars spaced 20 inches on center here, you might need to space them a little closer or even a little further apart. Now, these pieces of rebar right here usually connect to the stem wall rebar that will be perpendicular to them. And sometimes the anchor bolts might need to connect to the rebar also. I know that's something that a lot of engineers draw on the plans. However, it isn't always that easy to do. The next step will be to pour the concrete for your stem walls. And of course, now you can see why we have the shaped rebar here and our anchor bolts embedded in the stem wall concrete. And don't forget to lower one side of the rebar so that the other rebar will actually lap over it. And that will make a little more sense once I install the rebar grid that we're going to put in here. Next up, let's go ahead and remove the inside form boards and then just take another quick tour here of the interior and how the metal is separating the concrete from the wood. You don't have to worry about separating the concrete from the existing brick or concrete. Just make sure that it's separated from the wood. Now here's the next thing that might be required by an engineer, and that would be to install some type of a connector that would connect the home addition to the existing house. And that can be done using some type of a hold down that can bolt or attach to the floor joist, and then using some type of an all thread or long bolt like I have here. Now the advantage of using an all thread is that you could install a nut on both sides of the hold down and both sides of the square washer to prevent it from moving while you're pouring the concrete. And you can see here where something like this would definitely connect the two floors together. The next step will be to backfill this section right here with a solid fill material. And most of the time gravel is considered to be 100% compacted material. However, there might be another fill, something better in your area. And the fill will usually fill up to either the top of the stem wall in a situation like this, or if we have the stem wall going all the way up to the top, it's going to fill below the thickness of the floor slab. And in our example here, we're using a 6-inch thick floor slab. Yours might be a little smaller. And another example of how we have one piece of rebar lower. So the rebar going along this side here is a little lower, this one and this one. And the rebars going in this direction here are a little higher. And again, that's so that our grid will work out. You can see it right here. And I'm not expecting you to make this mistake here because I just told you about it. So the rebar running in this direction here goes under the rebar that's running in this direction here. And that is really about it for this video. Let's go ahead and start wrapping it up by just kind of traveling around here. And we can go ahead and pour our concrete slab. And that is about all I have to say about that. And I've only done this once, and I don't think I would ever do it again because it was a lot of work. And I really didn't know better at the time. I thought I was actually going to be building something better, which I probably did. But at the same time, I blocked off a couple of the foundation vents and actually had to install some tubing in the floor slab to allow air to go through this area. You might not need to do that. You might be able to get away with adding a few more vents on this side and on the other side over here. And of course, that was another lesson that I learned on some of my home remodeling projects. Here are a few more simple methods you can use to calculate the angles that you might need for a guardrail or even your hand railing. And even though I made a similar video to this, I thought that I would make one specifically for hand railing and guard railing, just in case some of the viewers can't find them. So basically what you're going to do is take two boards, and these boards should be the same size, maybe a 1x4, and lay one of the 1x4s on top of the stairway like this, and the other on top of the floor or the landing. And then just simply mark the bottom. We're going to mark this right here. We're looking for the intersecting points here and here. So mark the bottom and the top with a pencil, and that should look something like this. Then we're going to go to the other side and do the same thing. We're going to mark this section right here, and then we're going to mark the bottom down here. And then that's going to provide us with these marks. And then we're simply going to draw a line from this point to this point here. This will be the angle we're going to need for our hand railing and possibly the top of our guard railing. And this will make a little more sense when we take a look at the angle here and the angle here. I'm going to go ahead and line everything up so that it will make a little more sense to you. So again, we have this angle here from this board, and then this angle here from this board here. And believe it or not, these are actually the same angles on each board. However, it won't provide us with the angle here or the angle here. We're going to need to do something a little different there. And since these are pretty much the only two angles you're going to need to build a guardrail or a handrail like this one here, or most guardrails and hand railing miter cuts where they join something like this or something like this, then this project just got a whole lot easier. And to figure out this angle here and the angle for our balusters, we're simply going to grab another piece of wood, set it on top of the stairway, and then use a level or a straight edge. If that will work for your project, we're basically looking for a plumb line coming off of the top of the stair steps with our board here. And we can mark either side of the level. Let's go ahead and remove the level so you can get an idea of the line here. And you could also use a framing square if the landing or floor is level and the stair steps have the same measurements for the risers and the treads. This might not work as well if your stairway isn't built correctly. So if you do have a problem with some of these angles, that might be the reason why. Let's go ahead and cut our board and then kind of line it up here, give you an idea of how it's going to work out. For some of you who are imagining, how are we going to get this to work over here? We're just simply going to flip it around, turn it around until everything works out here. And obviously you're not going to have this right here because it hasn't been built yet. But I wanted to leave it in there to give you an idea of how everything's going to work out in case you're having a difficult time visualizing the assembly process, and how some of the angles are going to be the same and some of them are going to be different. So basically what we're looking at here is a 90-degree angle here, 90-degree angle for our balusters here, again 90 degrees top and bottom cuts. And then we have the angles here so that these boards will miter together. And then the baluster boards at the top and the bottom will be the same, along with the upper and lower rails if they're going to connect into a newel post. And for those of you who need the angle, just simply grab a protractor or a speed square and then line it up with the line on the board. And then it looks like we have about 32.5 degrees, maybe 32.25, but it is going to be 32.5 because I already checked with the software protractor that I have to find the angles here. And for those of you who are interested in learning how we can use math to figure this out, feel free to leave those comments in the comment area, along with any questions you have about this video, and I will answer them as soon as possible.